Dear children, in the class 7, you have learned winds and cyclones are caused due to the difference in the air pressure. Is there any relation between pressure and force? Let us find out. Here, a pin is in my hand. It is the head portion of the pin. When we push the pin into the paper, it does not make a hole in the paper. But if we change its end, if we put the sharp or pointed end of the pin into the paper and push it, it makes a hole in the paper. Why does these things happen? It means when we put the broad end of the pin into the paper, its area increases. Here the force is same, we apply the same force. But here the area, there is a difference in the area. The area of this head of the pin and the area of this sharp end, it is different. The area of the head portion of the pin is more than the sharp portion of the pin. Here see, when we push the pin, its sharp end, it is on the wooden block. So it pushes into the wooden block. Here is cylinder. Its surface area is much more. So when we apply force on this cylinder, it does not pull, its bottom end does not push the wooden block. It means here its surface area is more. So if the area is less, then we apply the force, then its effect is more. It means force acting per unit area is known as the pressure. So the pressure is the force acting on unit area of a surface is called pressure. So mathematically pressure equal to force per area, and SI unit of pressure is the Pascal. Factors affecting the magnitude of pressure. If the magnitude of force is more, then the pressure becomes more. Larger the force, the higher the pressure. Then the contact area. The larger the contact area, the lower the pressure. If pressure is denoted as P, so pressure equal to the force acting on unit area, and force here denoted as F, and the area it is the denoted as A. So here that is this force is F, and the pressure is directly proportional to the force. If the force increases, then the pressure also increases. If the magnitude of force increased, then the pressure increases, and the pressure is inversely proportional to the area of the object. It means if the area increases, then the pressure decreases. If the area decreases, then the pressure increases. So in case of that alpine, that pointed end, it has the less area, so its pressure is more. So it persists, but it makes a hole in the paper. And here another thing, what is the unit of pressure? Unit of force is the Newton. It is Newton. It is denoted as the capital N. And the unit of area is the meter square. So it is also written as the m square. So the unit of pressure is Newton per meter square, or another unit, or it is SI unit is the Pascal. And it is denoted as capital P and small a. P is the Pascal. Liquids exert pressure, also exert pressure, or pressure exerted by liquids. Here that is here we take a glass tube, and at the bottom of glass tube we tied one rubber balloon. So we put water into the this glass tube. When we put water, then this rubber balloon it slightly inflates. When we increase the height of the water into the tube, then the rubber balloon it inflates more. It means when we increase the height of liquid, it means weight of liquid is also increases. It means it exerts more force. So its effect is its pressure increases, so it inflates the rubber balloon more. So that is the liquid exerts pressure on the bottom of the container. It depends upon the height of the liquid column, or it depends on the upon the depth of the liquid. If the depth of the liquid increases, then its pressure also increases. Then in another example, here that is we take one bottle, then we make a hole on one side of the bottle, and to this hole we insert a glass tube, and at the end of the glass tube we tied one rubber balloon. Then we put water into it, and we see that this rubber balloon it also inflates. It means liquid exert pressure also on the sides of the container. It exert pressure on the walls of the container. So that is so liquid exerts sideways pressure. Then another example. In that example, we take one bottle and we make 3 holes at the same depth. Then we put the water into the bottle. So if this water, the height of the water, it exerts force or it exerts that weight on the container. So it also the water it flows from that holes, and here the flowing of that or the jet of water it is at the same pressure. Here it means liquid exert equal pressure at the same height. So let's do an activity. Take one plastic bottle and we make 2 equal size hole at the same height of the bottle. Here it is one hole, and at its opposite side here it is the another hole. Now we fill the water into the bottle. Now the bottle is filled with the water. Then we see that 2 jets of water flow from the 2 holes of the bottle. And here these 2 jets of water it fall at the same distance from the bottle. It means water exert pressure at the same depth. At the same depth it exert equal pressure. Let's do another activity. We take one plastic bottle and we make 3 holes at the side of the bottle. So here the depth of the hole is depth is less, or depth is smaller. Here it is the depth is more than that. Then here the depth. Here the depth is greater, and here the depth is greatest. So when the bottle is filled with the water, so when the depth increases, the pressure is also increases. So here the water, a jets of water, it flows it falls at a greater distance from the bottle. It means here the pressure is more, pressure is the greatest. But here the hole which is at the upper part of the bottle, here that hole, the hole which is the upper part of the bottle, here its depth is less. So the pressure is also less. So it falls at a less distance than the bottle. We take a bottle, we make the 3 holes at the sides of the bottle. Then we fill this bottle with the water. Now we fill the bottle with water. And we see here the water is coming from these 3 holes, and here that is at this hole, here the depth is less, so the pressure is less, and at the bottom the hole is here, that is here the depth is more, so the flow of water is also the water it falls at a greater distance. It means here the pressure is also the more. Gases also exert pressure. Air is a gas, air also exert pressure. When we inflate a balloon, it means it is due to the air pressure. Here also other gases also, helium, argon, hydrogen, oxygen, nitrogen, they also exert pressure. Then next is atmospheric pressure. You know the envelope of air around us is known as atmosphere, and the pressure exerted by the air around us is known as atmospheric pressure. So it is one phenomenon of atmospheric pressure. That is a drinking straw. The working of the drinking straw shows the existence of atmospheric pressure. Here that is the one end of the straw. It is it is dipped in the soft drink. Here that is in the bottle. That is it is half filled with the soft drink. So one end of the straw is dipped in the soft drink, another end is in the mouth of the child. Then the air inside the straw and at the mouth, here it has a reduced air, it has a reduced pressure, it has a less pressure. It means the inside the straw and at the mouth it has reduced air pressure. But the pressure exerted on the wall of the or on the surface of this soft drink is more, and it is equal to the atmospheric pressure. So it pushes the soft drink to go inside of this straw. So it is the existence. It shows the existence of atmospheric pressure. Let's do another activity to show the existence of atmospheric pressure. So it is a glass and it is a cardboard. It is a postcard. So now we fill the glass with the water. So now the glass is filled with the water. Then we put the cardboard on the glass. Then we invert the glass. And here the cardboard does not fall. The water, it acts the pressure, on the cardboard, but the air pressure, it exerts the pressure in the upward direction, and the atmospheric pressure is much more than the pressure exerted by the water. So the cardboard does not fall. Let's do another activity. It is a rubber sucker. It is made of the plastic. When we attach the rubber sucker into this flat surface, it firmly attached to the flat surface of this desk. So here the air inside the rubber sucker is very less, so it exerts less pressure. But the air outside the rubber sucker, it exerts more pressure. It means it is atmospheric pressure. Outside the rubber sucker is much more. So it exerts more pressure. So when you pull it, it does not come out. See, it means it also shows the existence of atmospheric pressure. Let's summarize what we learned today. Force per unit area is known as pressure. Pressure from solids is due to their weight and acts downward. But in case of liquid and gases, the pressure exerted by them is downward, sideways and upward. Also that means in all directions. The envelope of air around the earth is known as atmosphere. The pressure of the air upon the surface of the earth is known as atmospheric pressure. Thank you.